Welcome to the deep dive. This is where we slice through all that information noise. We pull out the really vital insights from our sources and basically give you that shortcut to being genuinely well informed. And today, wow, we're embarking on this incredible journey. We're going around the globe, diving deep into some of the most impressive modern engineering phenomena out there. Our mission, well, it's to get past just the impressive pictures. We want to unpack these feats of human ingenuity, show you not just what they are, but how they really push the limits of what we thought was possible. It's amazing how engineering and architecture now, they work together. They don't just solve problems, they create these stunning, sometimes iconic structures, function and form all blended together.
It really is true. And when you look at these projects, it's not just about big buildings or ambitious designs. You're seeing humanity's drive, this sort of relentless push to reshape the world, overcome challenges that seemed impossible before, across all frontiers, really. Deep oceans, even space. Each one is a leap in tech, a new solution, and just, well, a testament to human ambition. And they definitely impact society and the environment.
That's a great way to put it. It makes you wonder, doesn't it? Is this ambition all about progress, or is there also that element of sheer audacity? Can we really pull this off?
Speaking of pushing boundaries, let's get into our first marvel. Imagine engineering that just seems to defy gravity. We're off to northern France, to the River Tarn. We're talking about the Millau Viaduct.
Ah, the Millau Viaduct. Yes, currently the tallest bridge in the world. But what's truly revolutionary, I think, isn't just its height, it's how they built it. They used this technique called launching. Essentially, they pushed the entire bridge deck across the valley from both sides, piece by piece, with hydraulic jacks.
Pushed it across the whole valley. Exactly. It massively cut down the need for all that scaffolding you'd normally expect in such a deep valley. It really set a new standard for building huge viaducts over really challenging terrain. And, it's obviously a functional structure, but many people see it as a genuine work of art, too, how it fits into the landscape.
That launching technique,
Yeah.
wow, it sounds incredibly complex. Makes you appreciate the hidden engineering, doesn't it? Okay, so if Millau mastered the air above the landscape, our next one goes to an equally tough place, the depths below. We're diving quite literally under the Baltic Sea for the North European gas pipeline. You probably know it as Nord Stream. Huge underwater gas pipeline, two parallel lines, opened back in 2011 and 2012.
Yeah, and what really stands out with Nord Stream is the sheer logistical and technical difficulty. Laying that much infrastructure underwater, we're talking thousands of kilometers of pipeline. At pretty significant depths, it needed these really specialized ships and techniques. They had to make sure it was stable against currents, seabed shifts, geological movement, all while keeping the pipe itself intact under huge pressure. It was just a massive job, requiring incredible precision in deep-sea engineering. You're dealing with this constantly changing, unforgiving marine environment.
That precision, it's hard to even picture. Were there specific Baltic Sea challenges? I mean, beyond just the depth and getting it laid down.
Oh, absolutely. The Baltic Sea, well, it's known for having a pretty sensitive ecosystem.
Yeah.
And the seabed conditions vary a lot. Plus, there's unexploded ordnance down there from past wars. So the engineers had to navigate really strict environmental rules. They used advanced survey tech to map the seabed meticulously, making sure they disturbed marine life as little as possible and obviously avoided any hazards. It just added another layer of complexity.
Right, another layer entirely. Okay, from the sea depths to actually creating land, let's head to Dubai. The Palm Islands, these three huge artificial islands, right? Made through massive land reclamation by a government company, shaped like a palm tree with a crescent on top. The pictures of them being built were just astounding.
The ambition is phenomenal. Just deciding to make new land on that scale. Land reclamation means dredging unbelievable amounts of sand and rock from the seabed, then placing it precisely to form the new land. But with the Palm Islands, what's unique isn't just the sheer volume of material apparently enough to build a 2-meter wall around the Earth, which is wild. But it's that intricate design, keeping that complex palm tree shape stable, fighting erosion from waves, ensuring it lasts long term. That took a really deep understanding of marine dynamics and super precise dredging, like nothing done before. It wasn't just dumping sand. He was sculpting a whole new coastline.
Sculpting a coastline, that's incredible. Makes you wonder what's next for building on brand new ground. Okay, speaking of defying gravity again, let's go from building outwards to reaching upwards, vertically. Our next one, this really surprised me when I first read about it. The Beilong Elevator in China. It's in the Hunanshan Ongjianji National Forest Park. and it's supposedly the highest and heaviest outdoor elevator in the world.
Yeah, the Beilong elevator is a really interesting case. It's engineering pushing limits, but in a very sensitive place. It basically takes visitors up the side of this enormous sandstone pillar. The challenge wasn't just the height or the weight it carries, it was integrating something that massive into a UNESCO World Heritage Site. It's an amazing feat, no doubt, but it has sparked quite a bit of debate.
Debate about the environment.
Exactly. Environmentalists have raised questions about balancing this kind of grand innovation with preserving these incredible natural landscapes. It really forces you to think about the long-term impact of our ambitions when they intersect directly with, protected natural wonders.
That's a tension we see a lot, isn't it? Progress versus preservation. Where do you draw the line? Okay, from vertical journeys in nature, let's talk about connecting whole countries. Underground, the Eurotunnel. Such a crucial link between Britain and France. Takes passengers, takes vehicle shuttles, a real lifeline for travel, for commerce.
Definitely. And what's particularly innovative about the Eurotunnel, beyond the huge engineering challenge of boring 50 kilometers through chalk marl under the English Channel, is its unique operational model and ownership. It's managed by a private company, but one registered in both Paris and London.
Oh, interesting. A joint private venture.
Right. This kind of cross-border private enterprise running such a critical piece of international infrastructure was really groundbreaking at the time. It shows you the complex legal stuff, the financial frameworks you need just to keep a massive international collaboration like that going. It's not just about the drilling.
A marvel of engineering and international cooperation, then. Okay, let's shift our view now from underground. Let's look up, way up, to the stars. Next stop is Hawaii, home to PanSTARRS. That's the Panoramic Survey Telescope and Rapid Response System. And it's not just any observatory. Apparently it works 24/7, continuously scanning the sky for any fast-moving objects, asteroids, comets, things that might be a threat, or just new science.
The implications are huge. PanSTARRS isn't just taking nice photos. It's a really critical part of planetary defense, finding those near-Earth objects, hopefully before they become dangerous. The innovation is its wide-field survey capability. It covers a massive chunk of the sky way faster than older telescopes.
So it sees more, faster.
Exactly. This high-speed, high-volume data collection and analysis, it's essentially like a continuous high-tech guard for our planet. Crucial for safety, yes, but also for understanding how dynamic the universe actually is.
A continuous guard for Earth.
I like that. Okay, speaking of scale again, our next one is just immense. The USS G.W. Bush, docked in Norfolk, this massive warship built between 2003 and 2009, cost a staggering $6.2 billion US. And it's reported to be the biggest ship in the Northern Hemisphere.
When you talk about the USS G.W. Bush, you're talking about more than just a big boat. It's basically a floating city. A self-contained ecosystem, really. Advanced tech, power generation, highly integrated systems everywhere. The core innovation, I'd say, is its advanced nuclear propulsion. Lets it operate for decades without refueling. And also the EMLS, the electromagnetic aircraft launch system. Instead of the old steam catapults, this uses powerful electromagnets to launch aircraft. It's smoother, more efficient, but it demands a whole new level of power management and energy storage on board. It's really a peak of naval engineering. Huge power, incredible precision. That EMAL system sounds like a whole deep dive on its own. Okay, from these current giants, let's shift to the future. Something still being developed, but pretty exciting. Floating green eco-cities. These are concepts described as lily-pad-designed islets.
Right, the lily pad concept. This really makes you think about how we design for future challenges, doesn't it? Especially things like climate change, rising sea levels. These lily pad islets, the vision is for them to be entirely self-sufficient communities, intertwined, powered only by renewables, solar, wave, wind. The engineering challenge is immense, not just creating stable floating platforms that can handle the ocean, but also developing closed-loop systems for waste, water, food production.
Wow, completely self-contained.
That's the idea. It represents this, profound potential for sustainable urban development, reimagining how humans could live with the changing environment, not just fight against it.
A really optimistic vision. Okay, from future cities to one that is very much here right now, towering over the UAE, the Burj Khalifa. Used to be Burj Dubai, right? Renamed after the Abu Dhabi president when it opened. And our source said it was the world's tallest skyscraper until 2008. Packed with state-of-the-art systems, plumbing, aircon, elevators, even window cleaning.
The Burj Khalifa, it absolutely pushed the limits of reinforced concrete and skyscraper design to the extreme. One key innovation was its structural system, this buttressed core. It's a Y-shaped plan, It maximizes usable floor space, but also gives it much better stability against wind at those crazy heights.
That makes sense. The shape helps it stand up.
Exactly. And beyond that, the integrated systems were incredible too, like pumping water under high pressure way up to the top floors they had to create multiple pressure zones.
Right.
And the double-deck elevators, all working in coordinated shafts. These weren't just off-the-shelf systems. They were bespoke solutions designed for an unprecedented scale. Micro-engineering feats inside the macrostructure.
A vertical city, truly. Okay, finally, let's take a walk, a breathtaking one. On the Langkawi Sky Bridge in Malaysia, this is the longest pedestrian cable bridge in the world. 125 meters long, opened back in 2005. And getting there is unique too, right? You take a cable car up, then something called the Sky Glide, an inclined lift.
That's right. And what's fascinating about the Langkawi Sky Bridge is its curve. It looks amazing, but that curve makes the engineering way more complex. Instead of straight cables between 2 points, this bridge hangs from a single massive pylon. 8 main cables hold up the whole curved walkway.
Just one pylon for the whole thing?
Yep. The challenge was designing a bridge that gives you those incredible panoramic views, but is anchored securely in this remote mountainous jungle. They had to get materials up there by cable car. It's really a testament to how engineering can create these unique, almost ethereal tourist experiences while overcoming huge geographical and logistical hurdles.
Wow. Okay, so from revolutionary bridges and deep-sea pipelines to creating new land, elevators, climbing cliffs, scanning the cosmos, floating cities of the future, and sky-high walkways, we've really only scratched the surface today of the incredible range of human ingenuity in modern engineering. It is just astonishing what we've built and what we're planning to build.
It's absolutely clear these marvels aren't just structures. They are powerful statements, aren't they, about our collective ability to solve incredibly complex problems, to adapt to really diverse, challenging environments, and to constantly push the limits of what we think is possible. They embody that human ambition, that relentless pursuit of progress, often using completely new methods.
And that leads us to a final thought, something for you to maybe mull over. Considering all these incredible achievements we've talked about, what fundamental human needs or desires, what do you think really drives us to take on such immense, such ambitious engineering challenges? Is it pure necessity? Is it curiosity? Is it that audacity we mentioned? Or maybe something else entirely? We'll leave that one with you. Thank you for joining us on this deep dive. Until next time.